Hello, everyone, and welcome to another digital design class. As I mentioned last week, we're going to have our second exam this week. And before the exam, we're going to have a review session. This review session would help you with the upcoming exam. The questions will be very similar to what I'm going to solve today. I may change some numbers and tweak it a little bit, but it's going to be like 90% overlap with what I'm going to solve in the practice problems that we're going to solve today. So you are already familiar with my review sessions. I will start with the question. I'll give you a few minutes, 5 minutes, sometimes 10 minutes. The first student that is able to solve the problem gets extra points and bonus points on their upcoming exam. Without further ado, let's start with the questions. So the first question, we want to minimize the following expression using a K-map. So as you can see, the POS of product of sum, and we have to express it using the product of sums in K-map. Do you want me to solve it or you need more time? Okay, let me solve this one to make it easier. First, we have to find which product of sums or maxterms are this. This is M1 because C prime is 1. This is M3 and this is M7. So M1 is 0, M3 is 0, and M7 is 0. Now we need to combine them. So I'm going to combine these two. And I'm going to do it a different color. And I'm going to combine these two. Now, combining the red one, by the way, this is A prime. This is B plus C, B plus C prime, B prime plus C prime, and this is B prime plus C to make it easy for you. Now the red part would give us A plus C prime, and the black part would give us B prime plus C prime. So the final answer, Y, yeah, it's going to be A plus C prime plus B prime plus C prime. This is one way to solve it. The other way, you can just find the minterms and then find it as a minterm. So replace zeros with ones, and then find the invert or the use the Morgan's law to find the invert of this. If we do it with minterms, A0 is going to be A prime, A1 is going to be A. So it's just the opposite. So, and then we would have BC prime, which is B prime plus C prime. Now, let's solve another one. We have the following function. We want to reduce it using the K-map. Again, it's a max term, and f of a, b, c, d, here we have 4 variables, is the maxterms of 0, 2, 3, 8, 9, 12, 13, and 15. I usually write it like this to make it easier when we're doing the max terms. In a min term, these two were A, this was A prime, so the lower two rows were A. In the max term, it's opposite of the min term. So it's going to be A prime and A. Anything is opposite, it's reversed. Do you need more time or do you want me to? Has anyone solved this one? What is the answer? Yes. What is the answer?
B prime C and A times A.
You have to write it in the POS form, product of sums. Okay, let me solve it then. This is 0. Oh, sorry. 2, 0, 2, 3. So 0 is 0, and 3 and 2. So 0, 2, and 3. Then we have 8, 9. So 8 is 0, and 9 is 0. 12 is 0. 13 is 0. And 15 is 0. These are the zeros that we have in this system. Now we have to put them in groups of 2 and 4. So I'm going to put these 4 in one group. I'm going to put these 2 in another. I'm going to put these 2 in another group. And finally, I'm going to put these 2 in another group. Now, if I want to put these 4 in one group, it's A prime plus C. By the way, this is C prime and this is C. So it's going to be A prime plus C. Now these two are going to be equal to A prime, D prime, and we have B prime. So it's going to be A prime plus B prime plus D prime for that one. For these two in the corner, it's going to be A plus B plus D. And for these two green ones on the top right corner, it's going to be equal to A plus B plus C prime. So the final answer would be equal to A prime plus B prime plus D prime times or and with A plus B plus C prime and with A prime plus C, and the final one I have to write it down here, and with A plus B plus D. A prime, this is
So now, got my prime here.
okay, that's for a midterm. Max term is the opposite
Oh.
because you have to find. You can do the midterm for this, and then you find the invert. So replace all these zeros with ones, find the midterm, same thing that you did before, but then you have to find the invert of that midterm, the De Morgan's.
Is that why the primes have flipped?
Yes, as I mentioned, the primes have flipped. For a midterm, it's going to be AA prime. A is the A prime here, and A prime is the top two rows. So it's flipped. This is the easier way. The other way, again, as I mentioned, you can change the zeros to ones, find the midterm, as you normally do, and then you have to use the De Morgan's law to go from that midterm to a max term, which is going to make it more complicated and takes more time. In the exam, I'll provide you with the map that you would need for midterm and for the max term. But for the max term, the easiest way is just change the A's with A primes, B with, flip everything. The reason I solved two problems, you're going to probably have one problem in your exam, is because I saw some students had some confusions over the max term. And 90% of the time, we solve for the midterm, not for the max terms. Okay, so the next question, using a 4 by 1 multiplexer, we want to implement the following function. We have the K-map. It's a 4 variable system, and we have the outputs F, and we want to use this to and use a multiplexer to implement this. I solved multiple problems very similar to this. Okay, has anyone solved it? No? Okay. Do you want me to solve it? Okay. So what we do, and we have divided into the 16 different combination into 4 different groups. We will keep the 2 and the left from the first group of 4, A and B, and this is going to be our S0 and S1, okay? Now we will find the relation between F, C, and D. In the first one, what is the relation between F and C and D?
D.
Perfect, F is equal to D. So regardless of what C is, F is always equal to D. Now we will move on to our next group. And by the way, this is going to be I0, I1, I2, I3. So I0 is just simply D. Okay. Now, so if I select, for example, 0, 0, I would have I0 connected to the output and F would be equal to D. Now, for the next 4, again, A and B are S0 and S1. And if we pick 0, 1, the output would be I1. Now, what is the relation between F and C and D?
C prime D.
Perfect. It's equal to C prime. F is equal to C prime, D prime here. So for the second one, I can connect these two to an AND gate. And then I would have another NOT gate in their input. It's going to be C and D. And what about the other next 4? Perfect. F is going to be equal to CD. So this 4, I'm going to have just C and D for I2. And the last one, F is going to simply be equal to 1. No matter what the inputs are, F would be always equal to 1. So it will look like this. We have a multiplexer. First input is just D. Why do my D's become like my AND gates? But this is an AND gate. This is another AND gate. And the first AND gate, we have 2 NOT gates connected to it. The second one, just C and D. And finally, we have the output F and S0 and S1, which are connected to A and B. Okay. Now, next problem is very similar, but this time instead of having, and we're going backwards. So we have the function. We want to find the multiplexer to implement this function. And this is very similar to what you're going to have on your exam with the small tweak, small change. Did anyone solve this? What is D0? What is D0?
0.
Okay. D1. Okay. D2.
1.
Okay. And D3.
1.
Okay. And what about S0 and S1?
Oh, no, I'm sorry. I messed up.
It's okay. So the first thing you can, first of all, what you can do is you can change this to sum of products by adding y and z in each of the terms, and then have M0, M1, M2, and find it. Easier way just to replace it with the truth table. So for the first row, x, y, and z are 0, 0, 0. So 0 times 0 plus 1 times 0 is going to give us what? 0. So f for the first one is 0. What about the second one? 0, 0, 1. So z is 1, x is 0. So this would be 1, this would be 0. Again, what is the answer? 0. So f1 would be also 0. Now for f2, x is 0, y is 1, and z is 0. So 0. And by the way, because x was 0, x prime is 1. So this gives us what? 1. Now, what about f3? 0, 1, 1. X is 0, so x prime is 1. Y is 1. So we don't care about the other part, actually. It's going to be equal to 1. Now, next one, x is 1. Z and y are 0. So 0, this becomes 0, so this is 0. The next one, x is 1 and z is 1. So 1, 1. Therefore, this becomes 1 anyway. So this is 1. Number 6, or M6, is going to be equal to x is 1, y is 1, so x prime would be 0, and z is 0. So this is going to be 0. And when all of them are 1, it's going to be equal to 1. Okay. Now, if we want to allocate x and y as our S0 and S1, it's going to look like this. And there are multiple ways, by the way, to solve this. You can solve this using a 2x1 multiplexer as well. So S0 is y, and S1 is going to be our x. For the first one, f is I0 would be equal to what? 0, or f, because f is 0. So I0 is 0. What about the second one? 1. What about the third one? Yes. And what about the last one? So it's going to be 0, 1, z, and I can connect these two together. So put 1z or 2z, doesn't matter. So 0, 1, z, z.
How do you determine which one is S1 and S0?
That's a great question. So for example, if I put 1, 0 over here, what does 1, 0 refer here? 1, 0 is this 2, yes? What does it give us? I2. 1, 0 is equal to 2, which is I2, okay? So these two, the first one on the left is S1, the middle one is S0.
Oh.
The lower value and the higher value. So, and when you overlap them, you can see that it perfectly works. Now, another way that I can solve this, I can put x and z as S0 and S1, and I still can solve it. So I can put x and z as S0 and S1. So now these two are paired. This one and this one are paired, okay? And then when I pair these two, I can see it's going to be 0, 1 and 0, 1. So f would be here equal to y. So there are multiple ways to solve it, okay? I just kept the order, but you can mix it. You can make this x and z or y and z and still be able to solve it. Any combination, you can still solve it. I'm going to just mention how you do that. If I select, put S0 and S1 as x and z, then f x and z is 0, 0. Then f would be equal to y. So d0 would be y. If x, z are equal to 0, 1, then still f would be y and d1 would be y. If I'm going to write the rest here, x0, which is s0, s1, are 1 and 0, f would be 0, so d2 would be 0. And if both of them are 1, f would be equal to 1 and d3 would be equal to 1. So the only difference that you can see is that instead of having I2 and I3 being Z, it's I0 and I1, or D0 and D1. Let's make this I0 so it won't confuse you. Okay. Is it clear, or do you want me to? Clear? Okay. Now, let's solve another K-map. We are using this, we have this function, the sum of product. So it's the summation of m of 0, 1, 2, 3, 8, 9, 10, 11. And we want to simplify it. What is the simplified version of this? Again, I'll give you a few minutes. This is going to be actually an easy one. And the first person to get the answer gets extra point on the exam. Yes. Okay. Okay, what is the answer? Yes. So M0 is 1, M1 is 1, M3 is 1, M2 is 1, M8, M9, M11, and M10. This is A, B, C, D. Now I can combine all the ones at the bottom, all the ones at the top, and I will get B prime for this. Another one. We want to simplify this using a K-map. Did you solve it? What is it?
BD plus B prime D prime.
Okay, let's see. So 0 is 1, 2 is 1, 8, 10, 5, 7, 13, and 15. So what I can do, I can combine everything in the corner, blue one. By the way, this is an A, B, C, and D. So the 4 in the corner are going to be equal to B prime, D prime, 4 in the corner. And the 4 in the middle, I'm going to draw it in a green box so it's easier to, are going to be equal to BD. So the answer is BD plus B prime D prime. Remind me to give you the extra. Next question. We want to simplify the following function using a K-map. It's a sigma of 1, 2, 3, sigma of 0, 2, 3, 8, 10, 11, plus don't care of 1 and 9. So what is the answer for this? B prime? Okay, let's see. M0 is 1, M2 is 1, M3 is 1, M8 is 1, M10 is 1, M11 is 1, D1 is don't care, and D9 is don't care again. Again, because D1 and D9 are perfectly situated, we can combine them. If this is B, or it will be B prime. Now, to eliminate confusion, I want to solve another one of these problems. We want to use a multiplexer to implement the following function. F of x, y, and z is equal to x, y prime z plus x, y z prime. So x, y prime z plus x, y z prime. Okay, did anyone solve this? Okay, so if I put x, y, and z as 0, 0, 0, what would f be? 0. If x and y are 0 and 0 and z is 1, what would f be again? F would be 0 again. What about 0, 1, 0? 0. What about 0, 1, 1? What about 1, 0, 0? What about 1, 0, 1? 1, 0, 1, 1. What about 1, 1, 0? 1. What about 1, 1, 1? So again, different ways that I can solve this, but I can divide them to group of 2, and then S1, S0 would be equal to XY. And here F would be 0, F would be 0, F is equal to Z, F is equal to what? Z prime. So I'm going to draw let me do it with a different color. If I draw the 4x1 multiplexer, and I have X and Y, X and Y here, I0, I1, I2, and I3, I0, this is 0, I1 is 0. I2 is Z, and I3, I could connect this with a NOT gate. I3. Now, what if let's see. No, don't make it more complicated. You can think on it on the exam. But if, for example, the four ones was 0, the second 4 ones were 1, we can even design this with the 2x1 multiplexer. So we can make it even easier sometimes. Yeah, that's it for today's review session. Your format is going to be this. The exam format is going to be exactly like your first exam, and it's going to be the same time on this week on our next class. For the online students, I've already posted an announcement, and their exam is going to be on the weekend. Thank you so much, and I will see you on Thursday.